All right, so a quick refresher of where we're at up to this point, because we have 2 sections left after today we'll have one more, but today we have 2. 3-1, we talked about parallel, perpendicular, skew, and the special angles. 3-2, we said, okay, now if those lines are parallel, then what's true about the angles? 3-3, we said if the angles have special relationships like they're congruent or same side interior are supplementary, then the lines are parallel. And then 3-4, we started talking about slope. And 3-4 was a lot of algebra review, which is what's going to continue 3-5. That's the good news. Okay, number 1 said to find the slope of the line containing points 4, -3, and 5-2. So what's the equation that we use to find the slope when we're given 2 points? What's the expression that you use? Oh, sorry, I didn't catch whose hand went up first. Evan. Good. Y2 minus y1 over x2 minus x1. It doesn't really matter which one you pick as your 1s or your 2s as long as you're consistent. So if I said this was x2 and y2 and the other one was x1 and y1, it's totally fine as long as the numbers match within. Okay? And as long as I put the y's over the x's. That's the most common mistake people make, is putting the x's over the y's. Rise over run. So 2 minus a -3 over 5 minus 4, which becomes 5 over 1, or just 5. Questions so far? Okay, number 2 says line K passes through the points -1 and -1, 2, and 3, 5. Line N passes through 3, 6, and 6, 3. Are the lines K and N parallel, perpendicular, and neither? So how would I know if they were parallel? What's true about 2 lines that are parallel? Same slope. How about if they're perpendicular? Good. Opposite and reciprocal, right? So the change of the sign and flipped. And then obviously if they're neither of those things, then they would be neither. So I'm going to find the slope first of line K, 5 minus 2 over 3 minus a -1, which becomes 3 over 4. So that's the slope of K. And then the slope of N, 3 minus 7 over 6 minus 3, -4 over 3. So what's true about these 2 slopes? Are they opposites? Are they reciprocals? So what's true about those lines? Good. K is perpendicular to N. And then the last one says a highway has a grade of 7% for each 200 feet it goes horizontally. How many feet does it rise? So 7% would be what in fraction form? 7 over 100. So if we could think of grade as in as the road goes up, the thickness of the road increases. That's kind of like what a grade would be. So if it's 7%, then over 100 feet, it would go up 7%, which tells you how many feet it's going to rise over 200 feet. 14. Okay, so it's proportional. Okay, if it's going 200, if it was 100 and it goes to 200, it's doubled. So 7 would get doubled to 14. Questions on any of the warm-up? Yep. Sure. Yeah. 7% of 200. You could do that too. Okay, so it said to graph the line with the given conditions. It said through -2, 1 and parallel to the line through 3, 1 and 4, -1/2. So the first thing I would do is use these 2 points to get my slope. So -1/2 minus 1 over 4 minus 3. This would be 2 over 2 or -3/2 over 1. So the slope of the second line is -3/2, and it says it's parallel, which means I would keep it the same. And through -2, 1. So -2, 1 is here, and then I would go down 1, 2, 3, and to the right 2. And you can repeat that process again to make your line a little bit straighter. This is when your ID comes in handy, okay, because it doubles as a straight edge. But it should appear something like that. So if it had said perpendicular, what would you do differently? Flip it, and change the sign, right? So it would be 2/3. I would still start at the same point, but I would go up 2 and to the right 3. Any other questions on the homework? Alexis? All right, 3.5 is called writing and graphing equations of lines. So we're going to go a step further. Instead of just using the information to graph, we're actually going to use the information to get equations of the line, and vice versa, from the equation of a line, graphing the line. Okay, so, and hopefully mostly review, but just in case you need the refresher, here it is. Slope-intercept form of the line, which is y equals mx plus b. M is your slope, and B is your y-intercept. So you'll be given an equation and asked to graph it. So I'm actually going to start with B, because B is already in slope-intercept form, right? So all you have to do is identify what the M is, which would be what? Negative 1/4. And then the B, which is 2, and then I would start a graph. I would go down up to positive 2, which is my B or my y-intercept, and then use the slope negative 1 over 4 to get the next point. So that's if it's already in slope-intercept form. Is A in slope-intercept form? No, how do I get it in a slope-intercept form? Solve it for y, right? So I would move the 2x to the other side, so negative 2x plus 6. And then divide each term by negative 3. So most common mistake made here is not dividing all 3 terms by negative 3. So I get y equals negative 2 over negative 3, which becomes positive 2/3. X, 6 divided by negative 3, minus 2. With me so far? What's the slope? 2/3. And B, negative 2. So this time I start at negative 2 and go up 2 and to the right 3. What kind of line has a y and no x? Say again? Horizontal, right? The y never changes if it's horizontal. The y would always be the same value, right? So which is this case. So what's the slope of a horizontal line? 0. Okay. What would be the b? Where's it going to cross? Negative 3. So those are things that are like total memorization basis, because there's no way to solve this equation, right? There's only one variable. So I'd go to where y is negative 3, and I'd draw a horizontal line through it. So y without an x is a horizontal line, and a horizontal line has 0 slope. Okay, this one says write the equation of the line from the graph. So there's actually 2 ways to do this, okay, and I'll show you both. The first is from your graph, figure out what your y-intercept is and figure out your slope. So from this graph, which I can easily identify my y-intercept, right? What's the y-intercept? Okay, and then how can I figure out my slope? Nick?
Went to the right and then down.
Good, or down and then right, right? Because you want to do rise over run. So I go 1, 2, 3, 4, 5, 6, 6. 1, 2, 3, 4, 5, 6. So I went down 6, which is a negative 6. And then to the right, 1, 2, 3. Okay, or you could have gone the other way. You could have gone over and then down. Just make sure that you keep your signs the right way. Okay. So this tells me that my slope is negative 6 over 3, which is what? Negative 2.
Like down 2 onto the right 1 because it
If it passes through it perfectly, absolutely. Yeah. So can you use this point here? Sure. If it's a perfect point that crosses right through that little box, then you can use it. All right, so now from here, it should be easy to plug in, right? Because if y equals mx plus b, and my m is -2, and my b is +4, I've got my equation. Yep, so you can also use point slope. That's what you mean, right? Yeah, you can also use point slope. So like I said, there's a couple ways to do this. You could have, if you didn't want to count those points out, let's say they don't have a picture for you, you can find the slope by using the points, okay? But what Jacob's referring to is point slope. So depending on what information you have, sometimes it's going to be easier to use this equation, which is called point slope. Usually if you're given a point and the slope, it's easier to use point slope. An example like this is kind of just as easy to use the other one because you're given the y-intercept from your graph, okay? But from here, I would still need to know the slope, so I still would have counted and gotten the slope, but I wouldn't have needed to find the b. What I do is take one of these and make it, so I would get y minus, and pick either one. Let's say I pick that top one. Y minus y1, which is 4, equals m, which is -2, x minus x1, which is 0. And then from there, all I have to do is add that 4 over. So the first equation type is called slope-intercept, which is going to be the most helpful if you're given the slope and an intercept. And then the other is point slope, which is going to be the most helpful when you're doing a point and slope. You choose, though. You can get them either way. All right, this one says, write an equation of the line passing through the point -1, 1 that is parallel to the line with the equation y equals 2x minus 3. So what do we know about two lines that are parallel? Same slope. So what's the slope of y equals 2x minus 3? 2. So I already know my slope. Do I have a b? No. So this is a case where you're given the point, which is -1, 1, which is not 0 followed by a number. That's why it's not b. Okay? And then slope. So if I've given point and slope, which equation do you think is the easiest to use? Point slope. -3 is the b of the line that it's parallel to, not the line that we're trying to find. Lord. Because it has to be 0, 1. So in order for it to be this, the y-intercept, your point has to be 0, where the x is, and then the number. This is just a random point along the line. So I'm going to use point slope. So y minus y1 equals m times x minus x1. So y minus, this is my x1, y1. So y minus 1 equals m times x minus a -1, which becomes +1. This time I have to distribute and then add the 1. How can I double check to know that if it's parallel? What should be true about their slopes? Should be the same. Is the slope of this line the same as the original? Yes. All right, so again, one word in this makes the entire difference, okay? Instead of saying that it's parallel, this time it's saying it's perpendicular, which means I have to take this slope, which is -2, and do what? Good. Wait, what? Opposite reciprocal, which would be 1 over 2. Now I use that and the point. So y minus y1, which is 3, equals m times x minus x1, which is 2. Y minus 3 equals 1/2 x minus 1/2 of 2, which is 1. Add the 3. Y equals 1/2 x plus 2. Raise your hand if you got it right. Good. If not, figure out why not. All right, so standard form is the third form of a line. So we did point slope, and then, or so we did, start slope intercept first, and then point slope, This is standard form. So standard form is ax plus by equals c. The x and the y have to be on the same side. X comes first. X has to be positive. And they all have to be whole numbers. So the a and the b cannot be a fraction or a decimal. So you won't be able to plug into this equation, like they're never going to be given an A or a B or a C. But what it may ask you to is find the equation of a line in standard form. So you would plug into one of the other two and then move it around, transform your equation so that the x and the y are on the same side, the x is positive, and there's no fractions or decimals. So this says graph the line with the equation in standard form. So there's two ways to do this, okay? And, well, there's more than two ways. You could do a t-chart if you really wanted to, okay? One way would be how we know, right? Solve it for y. And then use the point and the slope to graph it. So try that way first. Okay, so the first way to do this would be the way we have been doing it, right? Solve for y, so I'd get 4y equals negative 3x plus 12. And then divide by 4, so I'd get negative 3/4 x. Divide by negative 4, sorry. No, sorry, divide by 4 is the first one. Plus 3. So then my y-intercept is 3, and I'd go down 3 into the right 4. Raise your hand if you got it right. Okay, so that's the first way to do it. Does anybody know another way to do it? Besides a t-chart. What's it called where this line crosses my axis? What are they called? What is B? An intercept. Are there two intercepts here? How would you find the intercept from an equation without putting it into slope-intercept form? Do you know? Do you remember? Plug in 0 for the other variable. So if I wanted to find my x-intercept, I plug in 0 for y. That's going to go away. I get 3x equals 12. And what is x? 4. If I do the same thing for y, so you always plug the 0 into the opposite variable. If I plug in a 0 into here, I end up with 4y equals 12. And then y would equal 3. So I can also use those two, 4, 0, 0, 3. Those are called your intercepts. So to find the x-intercept of any graph, not just a line, this will take you like my students are finding x-intercepts and y-intercepts of graphs that look like this and have asymptotes, okay? It's the same. Doesn't matter. X-intercept is when y equals 0, and y-intercept is when x equals 0. So if it says just graph, you can use whatever method you want. But if it says graph using the slope and the y-intercept, you would do the y equals mxb. If it says graph using intercepts, you're going to plug in zeros for both, find the intercepts, and then graph using those. Okay, understand? All right, so the rest is just some extra practice. This one says write an equation of the line in the graph at the right, and then write an equation of a line that passes through negative 2, 5, and 1, 2. I'll give you some time to work on it. All right, so one is using the graph. What can you tell from the graph? What two pieces of information can you get from the graph? The y-intercept and the slope. So the y-intercept is down here, which means b is negative 1. Good. And then the slope, if I count 1, 2, 1, 2, 3, my slope is 2/3. So y equals 2/3 x minus 1. When you get to b, do you have the slope or the y-intercept? No. Do you have enough information to find the slope? Yeah. So I just use those 2 points. 2 minus 5 over 1 minus a negative 2. Negative 3 over 3, which is negative 1. Do I have a y-intercept? No. So what are you going to use? Point slope. Does it matter which point you pick? No, you can pick either one. So let's say I'm going to pick the first one. y minus 5 would equal negative 1 times x minus a negative 2 becomes plus 2. Add the 5. Questions on either of those? All right, here's a lot more examples, and we honestly won't have time to work through all of them. But what I will talk through is like what you do with that information, okay? So if you look at number 1 and it says the x-intercept is 8 and the y-intercept is 2, what information do you have from that you could use straight off the bat? The y-intercept, so I know that 2 is b, okay? And then you kind of have options. You can say from here, this would be a point. If it's an x-intercept, what's 0? The y. So this is a point, and that's my slope, and you could plug it in that way. Or you could have graphed 0, 8, 0, I lost count, 8, 0, 0, 2, and counted from one to the other to get your slope. Or you could take these, which would be 8, 0, and 0, 2, and find slope that way. So there's a lot of different ways you can approach these. You want to do it whichever way is the most comfortable and makes the most sense for you. B says the line through 6, 4 that's parallel to y equals negative 2x plus 4. So parallel tells you what? Same slope. So m would be negative 2, and then I would use negative 2 and the point that they're given to find the equation by plugging in a point slope. Everybody understand that one? Okay. C says perpendicular to y equals negative 2x plus 4. What's that tell you? Slope would be? So it would be a positive 1/2, and then I'd use the point and plug it in a point slope. D is just like the last example we did on the last slide, where you'd have to find the slope first and then plug the slope and either point back in. E is your nice, quick, easy. This is your M. This is your B. And then F says a slope with 2 and the point containing 5, negative 2. So that's your point slope. So they're all going to give you a little bit different information, and some of the challenge is just where to go from it from the beginning, okay? So that's like pretty much wraps up 3-5, okay? Tomorrow we're going to talk about 3-6, which is some additional stuff with perpendicular lines, and then that's it for the material that will be covered on your test.